Good morning, good afternoon, good evening, wherever or whenever watching this. Welcome to a new Tech Talk video of flexible AC transmission system subject. And my name is A.V. Surendra. I am pursuing BTech final year in the stream of Electrical and Electronics Engineering. Today I am going to discuss about the basic types of FACS controllers in this Tech Talk video. Let's get started with this video. And in this video I am going to share with you these contents. First of all, basic types of FACS controllers, and these are four types, and there are series controllers, shunt controllers, combined series controllers, and combined series shunt controllers, and we will discuss all this in one by one. And first of all, the basic types of FACS controllers is the FACS device can be classified in two ways. General factor controller is like this. The, the basic FACS controller symbol, and by depending on the type of connection to the network, we will divide it in four types: series controllers and shunt controllers, and combined series controllers, and combined series shunt controllers. And when coming to depending on the technical features, the FACS devices can be divided into two generations. Those are the first generation one and the second generation one. And the first generation one is very uses thyristors and ignition controlled by SCR, and the second generation one is the semiconductors with the ignition and exit extinction controlled by GTO IGBT extractor. And this is series controller. It consisting of TCR and TSR filter as well in series with them. Line, this is consisting of the step down transformer as well. And the circuit on the first series controllers is it could be a variable impedance such as capacitor, reactor, or power electronics based variable source of main frequency, subsynchronous and harmonic frequencies, or a combination to serve the desired need. In principle, all series controllers inject voltage in series with the line. So even a variable impedance multiplied by the current flow through it represents an injected series voltage in the line. As long as the voltage is in phase quadrature with the line current, the series controller only supplies or consumes variable reactive power. Any other phase relationship will involve handling or real power as well. And series controllers of with storage is consisting like this, and without storage is like this. They are consisting of variable impedance as a condenser coil and inject voltage in series with the line as well. And this injects voltage in quadrature with the line current and consumes reactive power or not. Example: static synchronous series compensator SSSC, and and that is completed. And what is the importance of series controllers in our daily life? If the purpose of series controller is to control the current or power flow and damp oscillations, the series controller for a given MVA size is several times more powerful than the shunt controller. And the series controller can also be used to keep the line voltage within the specified range after all the voltage fluctuations are largely a consequences of the voltage drop in series impedances of lines, transformers and generators. Therefore, adding or subtracting the FACS controller voltage in series can be the cost-effective way of improving the voltage profile, but a shunt controller is much more effective in maintaining the required voltage profile at substation bus. So this is the importance of the series controller, and we will see the second one, the shunt controllers. As like the series controller, the shunter controllers may be the impedance variable source and the combination of these. This consisting of the combination of the both the impedance and variable source. In principle, all shunt controllers inject current into the system at the point of connection, and even a variable shunt impedance connected to the line voltage causes a variable current flowing hence represents injection of current into the line. As long as the injected current is in phase with quadrature with the line voltage, the shunt controller only supplies or consumes variable reactive power, and any other phase relationship will involve handling of real power as well. Like this only the shunt controllers will work. And the shunt controllers with with storage and without storage of diagrams is like this, and these are consisting of a variable impedance and variable source or combination of both, as I told earlier. And the injection of current to the system in the point of connection, and while the injected current is quadrature with the line voltage, it consumes reactive. Example: static synchronous compensator like STATCOM. Then, what is the importance of shunt controller in our daily life? These are the controllers is a good way to control voltage at any point of the connection through the injection of reactive power alone or a combination of active and reactive current for a more effective voltage control and damping of voltage oscillations. And it is very much more effective in maintaining a required voltage profile at a substation bus. One important advantage of the shunt controller is that it serves the bus node independently of the individual lines connected to the bus. So, like this is the most importance of the shunt controllers in our daily life. And coming to the combined series and series controllers, these are connected in series with, with one of the other in the AC lines, DC power lines. This is the combination of a separate series controllers which are controlled in a coordinated manner in a multi-line transmission line system, or it could be a unified controller in which series controller provides independent series reactive compensation for each line, but also transfers real power among the lines via the power link. And combined series controllers will. The term unified means that the DC terminals to be combined in the controllers are connected to achieve a transfer active power between each other. For the real power transfer capability of the line and a unified series to series controller, referred to as interline power flow controller, makes it possible to balance both the real power and the reactive power flow in the lines and thereby maximize the utilization of the transmission system. We can see here that series controllers along with the lines in DC links consisting of PAX controllers on board. And, and coming to the combined series controllers of the importance, these are very, as I told earlier, these are unified means that the DC terminals of the converters of all the controllers are connected to achieve a transfer of active power between each other. So a simple example for these are interline power flow compensators, IPFCs. And coming to the fourth one, the combined series to shunt controllers. This could be a combination of separate shunt and series controllers which are controlled in a coordinated manner. Means the individuality of the shunt and series. In this one, we are going to combine these both in one single diagram, one single operation, like this. Only on unified power flow control with the series and shunt elements, like this. Unified series is this one and shunt is this one. And And coming to the combination of series and derivations of the controller separated coordinately control and inject current to the system through the component in derivation of the controller. And serial tension with the line utilization and serial component when a serial and derivation controllers are unified. They can have an exchange of active power between them through the link. Unified power flow control is a better example for this one. And uh, at the end, and thanks for watching this. This is Surendra signing off.